Well, hi, good morning. Thanks so much for joining me in my shop here. So, this radio is now essentially working, but it's still not picking up any stations, and I'm pretty sure that that's because of bad alignment. Oh, if I start laughing in here in a few minutes, you'll know why. So, I think before I start fiddling with the alignment, I want to kind of x-ray this radio using my SDR receiver. SDR, software defined radio. So I have a radio receiver that's not much more than I guess really an antenna amplifier, and then the signal goes into the computer, and the computer picks it all apart and turns it into stuff we can hear in the speaker and stuff we can see on the computer screen. Not at all the way this radio works, not at all. So that's going to allow us to access a spectrum display, and we'll be able to look at signals going into the radio, and also, most importantly, signals coming out. So let's turn on the radio here. Okay. So this radio, like so many I have heard in my shop here, picks up noise pretty good. It barely picks up a station, if it picks up any at all. So it's able to receive stuff, just can't resolve any stations. So that to me suggests an alignment problem between the selected frequencies selected by the local oscillator and the front end tuning of the radio. Excuse me. So we're going to try and get both these things onto a spectral display, so we can see both the local oscillator, we can see where the pointer's set because we can see it, and also the front end tuning peak. So to help with that, I have another view here that includes the SDR. Let's just pull this down here. We can look at the radio about like that. Good. So the SDR radio is using this coil as an antenna. Just picked up a little bit of dirt. This is nothing more, and I've explained this so many times, but I know people are bound to try this. This is just a simple coil. There's nothing special here. You could use any coil. You can take a pencil, wrap wire around it 10 times. That's probably enough of a coil right there. So I'm going to use this to pick up signals from the radio and feed them into the SDR that you see up above on the screen there. And if I can just prove that this is the SDR, can I prove it? You can see the effect of my hand on it. Especially if I touch this, I think, if I... There. There's a little bit of exposed metal here. So I'm going to be putting this in locations where I have learned from experience it's easy to pick up a certain amount of signal from the radio. I didn't turn it on here, did I? Is it on? Here we go. Let's get it playing. Now, I experimented with this last night a little bit, and I got a really good result. So I'm pretty excited about showing you all this. Let's go back to the long shot. Now, part of the picture is, in order to see this as a spectral display, we need some kind of signal going into the radio at all frequencies. I have two choices. One is just the general noise. Not a terribly good choice because the noise is not uniform at all. There's hissy, crackly noises, and then there's actual false signals all over my house. So that's not a good choice because it won't give a nice smooth input. So another choice is to put in a purposeful signal from a signal generator, but then that would be at one spot on the dial here. So I've got a signal generator that will sweep that right across the dial if I have it set right, which I do. And so there'll be a signal just basically going up through the AM band. When it passes the tuning point, you'll hear it. Thump, 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 like that. Just for that brief moment, the radio responds to the signal as it crosses the point of tuning. If we if we look at the SDR, then we will see that at the point where the sweeping signal crosses over the tuning of the antenna on the front of the radio, there'll be a lift in the signals coming back out of the radio, just floating around the radio. That can be picked up with this. So in other words, as the sweep signal travels through this part of the band, the radio is doing nothing. It's not resonant. When it gets to the resonant point, somewhere around here, somewhere around 1,000,000, the way this radio is tuned, the signal going into the radio will encounter a tuned circuit. It won't be killed or absorbed. It will be supported. And because of that, it will be lifted out of the noise. And this guy will pick it up. Hey, let's do it. I'm talking too much. Why am I talking so much? For crying out loud. There's the radio. We're tuned to around 1,000,000, which is a good spot. Get a nice quiet spot there. Notice all that crackly stuff, other than what you hear right now. I think that's just coming on the antenna. Whatever was inside this radio that was crackling is gone now. Okay, SDR. Let's flip to the SDR view. So the first thing I'm going to do is I'm going to look for the local oscillator. So we know the radio is tuned to 1,000,000 or so. We don't know how well this is aligned. It's around 1,000,000. So we would expect to see the local oscillator show up 1,000,000 plus 4.55. Now I did tune up the IF in this radio previously. So so the IF we know is around 455 kilohertz. I'll finish that sentence. Yes, I eventually do finish my sentences. So here we go. So I've got the camera kind of aimed at the tuning capacitor. Now watch. So see, this one's attached to the antenna. Now this one is the one that's running the local oscillator. So I'm going to put the coil up near the local oscillator one and watch on the screen what happens. A new signal is showing up right on the 1 in 1400. The red line. The red indicates its strength. And you can see the peak is going off the top of the screen there. I'll lift it out of here. Oh, it's actually a stronger spot there. Notice it's not affecting the radio. There it is. I'm getting pretty close. So what I'm getting close to now, there's two sets of plates, there's 4 sets. There's two sets. These plates that rotate in most radios are actually grounded to the chassis. Whoops, I retuned the radio. Didn't mean to do that. Kind of ruined my demonstration. I should be able to touch them. Really no effect. The plates that are insulated away and have a signal on them, if I can put it that way, are these ones down here. See the wire leaving from these lower plates. They're called the stator plates. They don't go anywhere. They're static as opposed to the moving ones. And I just get this close to those plates. Voila. Now, to prove this is a local oscillator, I'm going to tune the radio a little bit here. Now, the SDR has a 1-second delay while it processes the signals it's receiving. So it comes 1 second later. If I put this over here, we can still see the local oscillator just because I'm close to these. It might be in here. Okay, great. So I've showed you how I'm picking up the local oscillator now. Let's get back to the radio here. First thing we want to do is check the accuracy of the pointer. Let me just get my camera here fairly level. There we are. I want to get it really lined up nicely on the pointer there. I think that's pretty good. So this radio is tuned, the pointer's almost exactly on 1 million. Okay, so that's 1 million right there. See, I'm checking it with my own eyes too. I hear a cat. What's going on out here? Ow. It's not Peanut, it's Shadow who's come in. Yeah. Now it may not look lined up on the camera screen, but look, it's just parallax, right? This has got this plastic piece is way out front of the pointer, so there's huge parallax errors. Oh, and I was going to explain something about these pointers. And I will. I will explain it. Let me find a fake pointer here. Oops, did I just yell into a microphone? I think I did. Okay, this will have to do. Yeah, my toothbrush here I'll have to do. How do, if you're trained in instrumentation, you know this already, but maybe you're not trained. So the pointer here is a flat blade like this. But of course it's not like that. It's turned like this. And then you sweep it as you tune. Here's the thing. If you don't look straight on this guy, you'll see the side of it. See that side, or you'll see this side. So when you're trying to line up, there's no precision in this radio either, but hey, who's here? What? Where'd you come from? Okay, I'll pretend I'm talking to you. Okay, Shadow. So, but nevertheless, they've gone ahead and put a big flat pointer on here that allows you to do this examination of the parallax. There you go. There's other ways to do it. That's the way to do it with this one. So let's do that. Of course, it's just a little tricky with the camera because you can't tell that the camera is way off alignment. So if I get the camera on pretty good alignment here, something like that. Yeah, it's not the best. Not the best on camera. But trust me, that's on 1 million. Now, where's the local oscillator? The local, if this is tuned to 1 million and this radio is really tuning in, 1,000 kilohertz, then the local oscillator has to be 455 kilohertz above, especially since I tuned the IF that way. So we will now put the local oscillator on the screen, and then just, oh, Cat, come on, Cat, what are you doing here? Oh, there's Cat. There's a cat in the shop. Cat. Yeah, I think she's fascinated by the sound. Okay, very distracting here right now. Come on, Cat. Oh, this, actually, you know what? She's never going to respond to the general name Cat. Shadow! Yeah, she doesn't respond to that either. Let us look now and see where the local oscillator is. I think I can get this even better on the screen here for you. How about like that? Okay, I'm going to put the pickup coil in place. Seem to wander around a little bit there now. And perhaps I'm affecting it with the coil. Okay, there we are. Looks like the dot in 1.400. Okay, so I'm going to take a look at what that frequency is. It was right here. Frequency is reported up there. 1381. It's supposed to be 1455. Okay, so what we'll do now, we'll do the opposite. We'll set the local oscillator to what are we going to do here? It's like some kind of Japanese monster movie going on here. Okay. Hey, fun at every turn. So now what we want to do is So with this, we want to make the local oscillator go to exactly 1 million. The cat's just throwing me off here, isn't it? Let's look at the local oscillator forced by tuning. What are you doing there, cat? Go on, get down. There she goes. Very good. We'll try and set this to exactly 1,455,000 rather. So it's because I haven't put the dial string on it. It's got that crazy piece of tie wrap. I don't know if I can stop the radio, make it stop in the right spot here. What I'm talking about is there's a plastic tie wrap. And you see it there, you can see it there. Plastic tie wrap instead of a piece of string. In case I haven't showed you that already. I haven't changed it yet. I should elevate that. So it's obvious putting the coil up close to the local oscillator is shifting it slightly. Okay, so how do I know I'm at 1,455? We're going to put that red line you see on the, I'm going to put this red line here right on 455 right there. Now, so the objective is to tune the radio until the local oscillator is on that red line. And then we look at the dial and see what we really tune the radio to according to the dial. Really? The really part? We haven't even got to the other half of the radio yet. Okay, let's get that over there onto the red line. It's just a... Yeah. That's not going to do it. It just won't go exactly there. Well, that's about as close as we're going to get. He says, trying to make it closer. Now hold it. Okay. What's it show on the dial? Okay, so it shows, I'm looking at my computer screen trying to do the parallax thing on the computer screen. That doesn't work there. So it's like 1080, 1090 instead of 10. So that's way off. So first of all, the pointer and the local oscillator are not in agreement here in this radio. Now we're going to look at one more tuning aspect, which is the front end tuning or the antenna tuning. I think in this radio they call it the antenna tuning. And we'll see how close the front end is tracking the local oscillator. Excuse me. So now we got to bring in that. I had mentioned my. Oops, wrong camera. This one. Let's get this guy going. Okay, I set this up last night. So this is now sweeping the entire AM band from 540 up to 1600. Something about this sweep is I have control over the speed at which it sweeps the dial. I can make it sweep really slowly or sweep really very fast. Last night I noticed that this machine appears to be sweeping at 1/10 the rate it's set for. So if I don't know what happened here. I'm going to try again. It's set to 1 second. What we should hear on the radio then is a bip every second as the sweep goes by. So here's something reoccurring. Click. That's supposed to be 1 second apart. So it should be So unfortunately my sweep seems to be slow and I have no idea why. Faster? Now that is supposed to be happening 10 times a second. That sounds like a second to me. In fact, that's a little fast, isn't it? So unfortunately we're not going to get the sweep rate we really would normally have. It's an extremely fast sweep rate. We're going to get that. Okay, we don't have to listen to it. That should sound more like a buzz than a woodpecker. So unfortunately that's what we're stuck with. But it's still enough to discover where the front end tuning is on this radio. So how am I going to do that? I'm going to use the same coil. Okay, down here now. Yeah, almost the same spot, only instead of picking the set of plates that are for the local oscillator, I'm going to pick the plates that are for the front end tuning. And just put this right in the same area. And I'll put in a pretty strong signal so we can get something out into the SDR to see it. Now at that point we can see where the front end is really tuned. I'm going to put this back to 1 million now. So as far as the radio dial is concerned, this radio is tuned up to 1 million. There you go. Let's see what really happens here. Turn this up a little bit so we can just be reassured that there's something going by. Okay, tuned to 1 million. So right around 1 million on the SDR, we should see a curve, a response curve start showing up. I'll put my finger down. Response curve show up. Okay, so we're going to turn up the input to the radio now. Turn down the volume here so we don't have to listen to this. And I got to put the pickup coil where we need it. I should have done it the other way around. Here goes the coil. I'm going to try to set it in place so I'm not touching it or moving it. How about like that? So I think we can see the local oscillator. Now, right at 1 million, you can see something kind of popping up occasionally, as if the curve is coming and going. And unfortunately that's because my sweep is sweeping at 1/10 its rate, or we see something a little better there. Let me just move the coil a bit. I think I can get a little better image of it. I had a great view of this last night. When, you know, this is how it always goes, isn't it? Things work great until you go to demonstrate them. So I had a curve on there that was gigantic last night. Why would it not be? Oh, I know why. I know why. I know why. So I'll show you why. So the way I'm feeding the signal generator signal into the radio is I'm just coupling two antennas. This is the radio antenna and this one. So, but I didn't really couple them properly. I need to have them a little closer together. That's a lot closer together. You can hear the difference. Let's take a look now. I'm going to put this. I'm going to put the SDR full screen at this point. Now we're looking around 1 million. Oh, I don't have the pickup coil in. Okay, put the pickup coil in. Right in here. Okay. I'm going to set it and let go of it. There. There we are. Okay. Now let's take a look at this. Now the image is bopping up and down funny because the SDR radio itself is trying to handle this like an ordinary radio signal. You know, I might be able to do something here with it. I let me just try. There's AGC built into these. Okay, let's try over here. So AGC appears to be turned off, and that's what would give the bumping. So aside from the point that it looks really weird up above, you can definitely see there's a red line roughly below 1 million. It's not right on 1 million though. The next question would be, is that really the front end tuning, or am I just pulling everybody's legs? So I'll tune the radio and we'll see if that front end tuning doesn't move. You can even see the local oscillator traveling downwards also. So what we'll do is, let's see, we'll set the local oscillator to 1 million. Can you get down there? Okay, that's stuck here, hang on. Okay, we're around 1 million. Stick right there. Perfect. Now we can see the radio thinks it's tuned to about, what would you say that is, 620. But if you take 455 and subtract it away from 1 million, you get 545. So the local oscillator is trying to bring out a signal at 545, but the front end is listening for one at 630. And that's why, this is exactly why this radio doesn't produce any reasonable reception of radio signals. It's listening in 2 spots at once. And I should even put it that way. I think you get the picture. I don't know if I have to explain any more about the significance of this. So our goal needs to be to get 3 things to line up. That's the pointer, the local oscillator, and the front end tuning. These things are all locked together by the tuning of the IF. In this radio, the IF has been tuned to 455. We'll check it at some point, but for now, that's where it is. We'll look at something interesting at 455 in a minute too. We'll try anyway. But so with the intermediate frequency fixed at 455, then it's a question of manipulating the other things. And there's 3 things. Right? There's a front end tuning, the local oscillator tuning, and the last one is the pointer itself. That's right. The pointer itself is an alignment issue in these radios. Now, my guess is this pointer is locked on in a certain position and really can't be rotated. But in a lot of radios, part of the alignment process is rotating this into its proper position. So once you get 3 interrelated variables, okay, it's really hard to adjust 3 things into the right spot. It's really tough. Look at that. See my fingers? I can hardly control them. They're never lining up. That's what's going to happen here. So I won't go into too much detail. We're going to assume the pointer is on the shaft in the right spot. It's been locked in this box. No one's gotten at it for a long time. And it could even be that this is one of those D-shaped or half-moon shaped shafts. This is on one way. It's not changing. So we'll align the rest of the radio now to fit the pointer. We'll do it at 1 million, even though it's so hard to get there. So with the pointer set here, the local oscillator should be producing a signal of 1,455,000. And we're going to make it do that. And we can do it with exactly the setup we have now. As soon as I can find it, a screwdriver. Okay. Not getting a screwdriver in there is a little tough. I think there's 2 adjustments in this radio. So my pickup coil is right in the way of the adjusting screw here. To move that, put it here. We're really interested in the local oscillator, so as long as that's on the screen now, radio's tuned to 1 million. Okay, so I'm looking to see if the oscillator is jumping around. No. So my metal screwdriver is not having any negative effect here. Now we're going to try to turn it. Moved a little bit. So this appears to be pretty tight. Which way are you going here? So I'm loosening it. So it's awfully loose now. That's not so good. I'm not sure I can get it up any higher than that. The screw is completely loose on the, that's not so good. Something funny going on. Now there's another capacitor in this radio. Well, I'm going to turn this kind of into the sort of the middle of its range, roughly. And I'm going to mess this whole thing up. I got to turn the radio over. Let me think about this. I think I can get it. Well, I can't do the IFs, but I can do everything else if I flip the radio over. So let's flip it over. Okay, I've got the radio flipped over here. The tuning capacitor's right here. Yeah, you can see it. And that's got to be the local oscillator coil. So this is another opportunity to pick up the oscillator signal. Let me just grab my antenna. And we'll see what... Oh, I gotta switch views here. Let me just put up the big SDR view. Okay, if we get anywhere near this coil, I'm pretty sure we're going to see, yeah, a local oscillator there. Perfect. Doesn't seem to move it around. Oh yeah, moves it around a little bit. I don't want this part, you can't see. No camera going here. Okay, so I'm just laying this on the radio as safely as I can. In fact, I gotta put this in a plastic bag here. Hang on one second. Oh, this is a little unnecessarily large. That'll do the trick. Put it like that. Of course, I'm covering up the. It's quite clear where. Yeah, no, I'm not covering up the screw. Oh, let's get the other view on here. Maybe we can see the whole shebang here at the same time. Okay, local oscillator, are you affected by this? I'm going to move the bag. Oh, well, of course it goes away. Okay, moved it too far. Move the bag around. So it's not wobbling around. A little bit there, maybe. Oh, it's the signal strength going up and down, that's all. Just getting stronger as I go. Okay. Now, this thing was supposed to be adjusted mid-band, and it had a funny name for it. I don't remember now. First, any sensitivity as I touch the capacitor. I'm using a metal screwdriver. A little bit if I bang it hard enough. Okay, now we're going to turn it. First of all, it's kind of mid-range. It's definitely moving it. And we want this up and the other one down. We're doing this in the middle too, which is kind of fortuitous. Let's see what kind of range we've got on this. Lots of range. So we're well into its operating range, so to speak. Let's put it 14. It was supposed to be 1455, right? Did I put the red line there? Yeah, so the red line above is set by me, and I'll match it right now. So the local oscillator is now attempting to match a signal of 1 million. In the front. Now, so we should now try to make the front end tuning match 1 million. Did I mess up the dial? Is the dial still on? Exactly 1 million. It doesn't look good. Oh yeah, there we are. Parallax 1 million. Perfect. So now we'll try to get the front end to do the same. You're not going to be able to see the front end. Front end tuning. It's a little hard to get to here. So the front end tuning slug, I think maybe you got to go through the hole here. That kind of seems kind of crazy, but that would help, going through the hole in the cardboard there. I got to get the antenna pickup somewhere where it can pick up the front end. Remember all the trouble I had with that? Oh boy. So I'm just gonna, just with luck, stick it. Just wind it in among these wires here. What do we get? What do we get? Oh, I don't know what we got. So the radio's tuned to 1 million, so right around 1 million we should see a little peak thing jumping up. I don't see a thing. Oh, antenna. I do not have the antenna coupling set up properly. So I'm going to bring the, let's call it the transmitting antenna, up to the receiving antenna here. There we are. Perfect. Except now I blocked the tuning, the access to the tuning screw. Okay, I think I can get there. It's a little crazy. Sorry about focus not being quite right, but through the hole, through the other hole. Past this. Oh my gosh, there's so much stuff. Okay, I got it now. Can we still see this? Yes, we can. So back this now down to the 1 million. Okay, stay in there, screw. Ah, it fell out. Stay in there now. Okay, the screwdriver keeps dropping out. I'm ready now. Move down, down. Is it moving anywhere? Tell me I'm just turned the wrong screw. Didn't seem to do a thing. Jim, which screw did you turn? Oh, it's the right one. Okay. This is just crazy. So we have this local oscillator one set the way it is. So let's... I just can't see what I'm doing here. Ah, man, grand. There. Man, alive. The other way of doing this is the rocking technique, which I'm not good at, apparently. I'm not good at it. The rocking technique, you're trying to actually adjust two things against a third. What you're trying to do there. This is a lot more direct. Okay, I'm in on the screw. pretty close to 1,000,000 now. Okay, so that's loosened right off. Let's tighten it up. You can see it below the 1,000,000 there. I'd say that's it. Okay, I double check everything now. Is it tuned to 1,000,000? Yes, it's 1,000,000 on the dial. I just checked. Is the local oscillator at 1455? Okay, and let me take a closer look at it here. So the red line, this red line up here is at 1455. The local oscillator is just off. It's just below it. By how much? Instead of 1455, it's 1448. So let's see if we can't move that oscillator. Hang on a second. Again, I apologize for the focus. Hey, there's no need to apologize. I'll put on autofocus and we'll see what happens. Okay, now, coming on the local oscillator. So these adjustments is what will make a radio really work well, getting this right. Okay, so we want to try to move that oscillator onto the red line. It appears to be on the red line to me. There we are. Pointer on 1,000,000, front end on 1,000,000. So we know at this point on the dial everything is lining up great, and it's probably the case right across the whole dial, but we don't know that yet. All we know is that this thing should be working really well right here. Now there happens to be a medium strength AM station at 1010 from Toronto. We should be able to pick it up, so I'm going to turn off the sweep so we're not hearing that at all. Turn up the radio a little bit. So we should pick up a signal just slightly higher. Not to panic, this is a tough one to pick up. Okay, we're no go on that. So we will try down around this area. It's getting quieter, so probably the front end is drifting off, maybe not. Okay, I can't get past here. Now, strong AM stations down here. Come on, radio. So that's 590, I'm pretty sure. We're talking about sports. Take my camera by hand here. $590, anybody? So much for the autofocus, eh? It doesn't work with a hoot. Okay, so that's 590. Let's try 640. Silence. Silence. Yes, silence. Okay, so that was a somewhat disappointing result there. 590 should be coming in powerful and clear. 640 should come in strong. 680 should come in with a little bit of interference. That's the way good radios work in my shop. This one didn't do that. So, a lot more alignment issue. We should check the front end at this point and see if the front end is matching the dial setting. And then that's got to be the end of it for me today. So let's do that. We'll do it right where the signal is. We'll do it right at 590. How about that? The only thing that can be wrong, the pointer is correct, the signal we're receiving is correct, the local oscillator has to be correct for that to work. So the only thing that could be wrong is the front end. Okay. We can kind of check that with our ears. I'm just going to tune the front end back and forth. Does it get any louder? That's my hand. Okay, so I'm ready to tune it this way and that. Does it get any better? Couldn't hear a change. Put it back. No, I couldn't really get any more out of it there. So, you know, this might be the limit of this radio. That this might be what it does. Let's go through it once more time. One more time there. No. There's a good one at 740. Seems louder up here, eh? It seems way louder at the higher end. Is there another tuning slug I'm missing? No, there isn't. Well, I think maybe this is it for this radio, unfortunately. What else could we do here that would help to improve it? I'd have to find another adjustment. The IF. Maybe the IF is... We did the IF under very difficult circumstances. So why not try and boost up the IF? You know what I'm going to do? I'm going to stop at this point because my time has run out here today. But tomorrow I will go through the whole thing again. Well, we'll see. It's Easter weekend coming. it's Muller time too. So I may not get back in the shop for a few days. Got company coming and all that kind of stuff. I'm sure my wife has other plans for me. Yesterday I was wielding a paintbrush, so I may not get back at this for a few days. But I think that's what we need to do. Just redo the alignment just to make absolutely sure everything is as good as it can be. And then it is what it is at that point. Great. Anyway, it's working. It's a far cry from where it was when I started. That's for sure. Thanks so much for watching. See you on the next video.